first we will take a look at the 2.4 subtopic, which are related to the linear time invariant systems. So for the last week, basically we had discussed about what is the linear is all about and what is the time invariant, right? So, and then the system itself is the system, meaning okay, right. So if we discuss it in illustration, that would be this one, x and y, and this one is h n. Okay, so okay, right. So for the LTI system, meaning for all this, by its impulse response. So the impulse response, meaning Hn, while the impulse response is related to this unit sample, right? Remember last week? So this is actually the one that been focused on this subtopic as the priority is actually considering the impulse response as this unit sample. So the H itself is coming from this what do you call it? This one. Okay, right. So the LTI system stated that any given Hn, it is possible to compute the output. So this is the output, Yn. So this one, and due to any, the keyword is any. So any given input through this given impulse response Hn, we can compute the Yn. Okay, right? So this one, it's possible to compute Yn if we have this one Hs for any. So it's actually kind of it's a shortcut or something, we can say it a simple way. So this one is actually the bottom side of the equation is presenting the this one is the output. Okay, so this one is the input, so this one is the operator. So meaning if we want to calculate this one, so by any means of xn, so we can have the whole lot of yt without with the given this one impulse response as this. Okay, so this one is actually relates to this one unit sample. So unit sample has been used for finding the impulse response. It relates to this, so whereby this one is actually can be computed as this way. Okay, so this one is meaning a t internal component with this internal component is actually equivalent, meaning linearity. Okay, so while if we take a look at this one, so say that we have the operation with the internal bracket of this long function with this one. So okay, let's say we put it in this transform and put it out something like this one. We put it out and remain the t, and we just focus on this. Okay, so this one basically reflects to this function, right? It's any. Okay, t. Okay, no, mean. Okay, k. So at the end of the day, we can say that this one, delta and k is related to this. Okay, as it is this hk. Okay, let's say we put it hkn over here, so it can be represented as this. So that's the reason why you can see over here delta and k with hkn, right? It's actually from this equation. So meaning to say that the time is time invariant and later is actually follow this condition, these two conditions, 1 and 2, is actually known as this. Okay, so at the end of the day, we can simplify then this equation by, okay, this one could be explain HK, right? So HK is actually, if we want to portray it in H, impulse, not in delta, because this is the same. So we can say that HK, XK, HNK is actually this XK. So this is actually the response, meaning to say that if we multiply this component A with this B, say that we have this operational, so we can say the convolutional of xk and hk is actually this reply to this, okay, yk. So that would be the background of the first page. So and then speaking of the impulse response, so what is impulse response is all about is we know that this is actually this one, right? Okay. Okay, for this one, it's unit impulse. Unit sample. The response for discrete. So the response for this is called impulse response. So meaning the impulse response for this is actually from delta n. Okay. So typically, yeah, it is known as this. Okay. So in a discrete system, no, so normally the input known as if we have consider x and the input we have is this, so just ignore this one. So this one is for n. So let's say we have this. Okay, this one is the output that we have. So when input is delta, so then this this one is response, right? So what is this one? H. So the H is basically this term, impulse response. So be careful about the term. So if we have this as the input and this as the output, so meaning to say that we have this would be impulse response again as this one, right? Okay. So impulse response is actually the dn with xn, and we have the long summation of x and d, so meaning the multiplication of that. Okay, so why it is important is basically the relation between when we have the input as delta and the output as the h is basically when we consider this to be the priority of our case. Okay, so say that here, okay, considering the following system, so the system is, so this is the response, right? Okay, yn. So the impulse response for the system can be obtained by setting the input. Okay, so this is referred to this. By setting the inputs to the impulse response. Okay, so where's the input? So the input is basically, so the input is this. So the input is this. The input is this. And the input is this. So meaning this is the input. So while this is the impulse sequence. So we have delta n is actually n this 0, right? So if say that we have delta n plus that minus 1, we have this one, right? So etc, etc, etc. So meaning that say the combination of many unit sample will be having the, what they call it, sequence, right? Okay, so the sequence is actually multiply with this alpha. So if you can see, so each of the component is actually multiplied by this and this and so on. So that's the reason why we can simplify this h only. For h is actually hn with this. Okay, okay. So we reflect this equation. Okay, so this is the component of unit sample, right? So this is hn. So in other words, to portray the HM with the unit sample is actually multiplying this unit sample with HN, the component of HN. So whereby this HM is similar to alpha 1, etc., etc., right? So we can say that if we put all the M, okay, let's say minus H, H minus 1, H0, and etc., etc., sambung. Okay, so we can see that this is actually the combination of this and this from minus infinite, minus infinite minus 1, minus infinite plus 1, minus infinite plus 2 until minus 1, 0, 1, 1 plus 2, 3, 4 until infinite plus 1, infinite. So this is actually we can say that the H is actually a combination of this value. So this is might be important someday. Okay. So that would be the original view of what we have discussed before. And then, so I think this should be no problem. Okay, recall. You remember accumulator last week? So yes, by considering the 3 pages, the previous 3 pages that along which we discussed this X and HN, right? Okay, so if we have the output as this, okay, so similar to this one, so this is equal to this. Okay, this is summation without alpha. Okay, so what is the impulse response? So what is the impulse response? The impulse response is actually to find this for the system. So meaning to say, the question is asking about the impulse response itself, about this value equations. Okay, so when we talk about impulse response, we take a look at the page number 5 over here. So meaning if we have the output given, we can find the impulse response easily by converting the xm to the delta, right? So in other way around. So meaning to say that if we consider the output is delta, this is unit sample. Okay, so the hn itself is actually converting to the y, and this is delta, similar to this and that. Okay. So by having this this value, meaning the response itself over here is actually the combination of the delta from minus infinite, let's say this, until n. Okay, example, so this. Okay, so whereby this one, if we have if we change the finally we can conclude that hn equal l minus infinite to the n dl and n. So basically for at certain condition of this until this, okay, so meaning the minus infinite is actually coming from here, so meaning this one, right? So this is actually not suitable for this example, so meaning from minus coming until 1n, this stop. So this one would be 0. So basically we can say that the hn is this. Okay, probably this one would be minus, not plus. Okay, if plus, then this would be something like 0 to infinite or something. Okay, it would be opposite. So this one is a step function by minus n. Okay, so meaning the reflection of, if we can, if you remember this one, hold on, sorry. So we go to here, go to here. So if you remember this one, ini dia bagi infinite and this one, right? So this one is un and this one is un minus 1. Okay. So remember about last week, this delta n can be shown as this one. So meaning, say that if we have this n and this n plus 1, right? So meaning this is actually cancel, so meaning the remaining will be this, reflect to this. Okay. So that's the idea of the unit samples and step. Okay. Today we have 37 slides basically. There will be example at the end of this slide. So hopefully we can take a look briefly later on. Okay, so the impulse play a monumental role in the characterization of LTI system. So impulse response. So meaning this again. So I keep repeating the Hn and Yn and Xn is because I want to make sure that you know what is the impulse response is all about. Is H. Okay. So this is actually okay. In fact, that you know the impulse response. So this one is impulse response for LTI. Then you know the response of the system is any. Okay, this is Y. Okay. So then, if say that you tell me H, and I will tell you the any. I will tell you the response. Okay, the response is Y, right? To any xn. Okay. So then, in other words, if we want to find this one, so we need to have
N.
yes, any, right? So this one is the keywords any. Okay. So the response is there. So normally we will have the response over here. So this one is could be in. Okay. So remember about this x, this h, this one. Be careful about the terms. This and this one is output or response, right? Okay. So this could be easy if you know the terms and so on and so forth. So that one is that. To see, consider this one is recall. Okay, this one is sequence, the one that we have covered last week. This. So it's I think it's easy because this one is X. Remember? This. Be careful, eh? Okay, so how we read this thing is, okay, take a look at this. This is x1. So this one, it should be here somewhere. Okay. And this one could be here. This one is here. This one is there. Okay, meaning this is -1. This is a 0. So every single x location has their own value. So meaning x0 is, okay, x1 is, recall that any sequence can be represented as a sum of impulse. Okay, sum of impulse. Okay, so this one, the sum of impulse, meaning this is the sum. Okay, so the xn is actually the equation for the input, right? Okay, so the meaning, the function for the input is actually the sum of the impulses. So this is, oh sorry, I changed. This one is one impulse. This one is 1, 2. This one is one impulse. And this one. So every each has impulse. So this component plus this component plus this, meaning to say that we have a sum of impulses. Okay, so that's the reason why we can see this one. Okay, so then if we put it in, we put it in the right way. So let's say, so delta n is n equals 0, right? Delta n minus 1 is n, etc. So n0 meaning we have -2, right? This is 0, this is 1, this is -1, this is 3, right? So this is actually the sequence of input in a sum of impulses. So this is what we call it input. We can say function or something. Okay. For the LTI system, we can add the individual response for the system. Okay, so then the individual response. So this is the individual response. So what is response? Y, right? Of the system to the individual input. So what is the individual input? Okay. Of the input sequence. Okay, so meaning to say that we have this one is X. This one is input sequence. So each individual input we have this. It's actually taken from here, right? So this one is this. Okay. So remember that last time in page 1 to above that we can consider it the delta to X, right? So this time around is delta to H, as this is actually our priority right now, Y. Okay, so meaning if we have the delta over here, we can convert it to the H. So we can have the equivalency of that particular page. Sorry, for rewind. This one. Okay, so that one is another angle because we are discussing on the H right there. This one. Okay, so but this one is we are discussing another issues of finding the other way around. Okay, so the Y here is basically minus 2 Hn 0 this and this and that. Okay, so we can see that this one is actually that. Okay, for make things clearer. Okay, so this is actually the one that we have at the end of the slide 9. The output is actually the convolution, remember, of input and impulse response. So meaning we can this one is, what is this? Again, the normal multiply in such a summation in equations in summation and so on and so forth. So this is actually the one that we consider by reading this equation, meaning plus etc. So this is actually the each component, the multiplication of each component whereby m equals 0, x 0 and n 0. So this is actually happen at that particular moment, and this is combination and that to portray the convolution in illustration by the normal multiplication. So meaning, okay, let's say this is x, right? This is h. Okay, this is x, this is h. Okay, so how we can get the yn as this one? So y0 equal minus 2. So by looking at this, can you do the calculation? Let's say 0, right? X0 and H0 convo. You can do by the maths if you know, but if you in the normal calculation, so how we do it? This one is X, right? This one is H. Okay, so this is keyword over here. Okay, so in other way around, X0, this one is X0, right? This one is Hn. So why the only X0 multiply with all this? Can you give the explanation on convolution by looking up the equation? If you take a look at this, 0, minus 0 multiply with all this component of hn minus 1, this. So in other way around, if we have the graph, let's say we have A and B right over here, so then we understand that this is actually, the h is similar to this. Okay, so this is m, this is minus n. Okay, so remember the things that I wrote to you just now. What is different, this and this? So this one is right, 2D. How about this one? 0. Anyone?
The opposite direction.
They looks like this, right? Okay, so yeah, the easy way to get into the convolution is actually reflect to this equation. Okay, so one is the normal direction, the one is the other opposite direction, right? Then we later take a look at how we gonna deal with this. So basically, if we say that this one is actually reflection of the opposite direction of h, so basically this would be, dia macam ni, kalau this Sn, dia saya padam. Okay, so nanti dia akan jadi this, 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 and this. So ni 0, ni minus 1, minus 2, minus 3, minus 4. Tapi this still the m. Right? So maksudnya dia terbalik, dia mirror. Okay, then if we, this one, x0 ni, so itu that's the reason why we need to deal with the illustration is easy in finite examinations, because if we take a look at this, yang okay, hn minus m 0, okay, what is the value for xn over here? This, what is the value? Anyone?
Two.
Not 0. Okay, this is un, right? Ni, nampak eh? This is un minus 1, minus n, u minus n, right? Kalau gambar ni, susah juga macam mana. This graph, saya terbalikkan ke kiri. You boleh bayang tak? Dimension dia.
Delay.
Saya pergi ke sana. So maksudnya, yang this one ni, is reflect to this, right? Yang ni dia reflect to this. Yang ni dia start daripada kiri ke kanan. Yang ni kanan ke kiri. Similar to this one, right? Kiri ke kanan, kanan ke kiri. Can you get me?
Yes. Okay.
So that's the idea. Nanti kita akan tengok the easiest way to get. So later on we will see what is the practicality and the how the implementation in real. I think it's like 20 something. I guess later on we'll discuss on it one by one.
Okay, thank you guys for watching NMZH channel. Hopefully you can get knowledge and benefit from the videos. Thank you so much. Assalamualaikum.